Well, I
Oh,
can say, good God, man, I'm a doctor, not a bricklayer.
You're
Well,
on
we're
the
gonna
air.
we're gonna find out. I think we're ready, Mr. President.
Yes, you are.
Hello, everybody.
oh,
Welcome again to the little vlog podcast that could, doggone it, Santa Barbara Astronomical Units online Zoom gathering every Monday morning at 11 called the SBAU Astro Hour. It's now officially convened on screen, our 238th time together here since early 2021, where we kick around cutting edge cosmology, sail through the cosmos in the style of astro icons like Carl Sagan and Brian Cox for yet another hour. I'm proud host Ronnie Heron, and I'll be joined by the members of the SBAU in a moment. Introduce you to them for this week of September 15th through the 21st, and our program devoted to these topics. NASA just announcing their Mars Perseverance lander found something possibly linking it to life. Could be finally. We got three comets to talk about this week. C 2024 E1's getting brighter. Another comet, the one that's visiting an interstellar that's going through, is growing a tail. And a third has emerged from behind the sun. The Owl and the Pussycat. Wait a minute, we're not a book club. No, the Astro stuff. The Owl in Cassiopeia.
aha.
Good old NGC 457 we're going to talk about. Early this coming Friday morning, pre dawn, we get a 3-for-1 conjunction you might want to check out. And in 6,000 light years away or so in the Milky Way's Perseus spiral arm is the Heart and Soul Nebula, part of which looks like a heart. Welcome aboard. You're invited to join us at the Santa Barbara Museum of Natural History for our first Friday of the month general meetings. We got a big one coming up in 2 weeks. Our second Saturday star parties we just had at the museum. Out and about everywhere. Telescopes from Westmont to Camino Real Marketplace to the lakeside and the beach, park, schools, everywhere. You're invited. Or online, sbau.org tells you all about us. Let's meet them. I'm the vice president. Here is the president and commander of the Starship, Jerry Wilson. Good morning, sir.
Good morning, everybody, and good morning, Joyce, and good morning, Riley, and good morning, Calvin.
And who was that old lady that Jimmy Durante, Miss Cavendish?
Um, and what was that? That was
Calabash.
Jimmy Durant. Yeah, Mrs. Calabash, wherever you are. Jimmy
Welcome.
Durante's sign off.
That's right.
No
And
one ever figured out who she was or where she was.
Oh, they
I,
didn't?
I think I think that little woman with the glasses that sat in the audiences of TV shows in the 60s, what is her name? Mrs. Miller? Remember her? Does anybody remember?
No.
You
Nobody
mean
Uh,
remembers.
where's the beef?
Chuck,
yeah, yeah.
Chuck McPartland is our outreach guy, is on screen, co-pilot of this incredible crew. His wife, Pat, is merchandise manager. Jerry's wife just ducked her head into the screen before we went on. Pat Forgy, good to see her. All these supportive wives. Here's Tim Crawford. His wife is Karen, and he's an expert on incredible things except giving speeches on our only night or running for office. He's a very smart man, this guy. And we have sillies to do every week. Look forward to these. It always gets us off into a fun mood. Silly science cartoons that are these days forwarded last minute on a Saturday or Sunday to us. And we got 7. We'll see how many we can recreate on the screen, ladies and gentlemen. You're going to have to definitely raise that up. That's the one about, ah, is that Brewster Rocket? Not Booster, but Brewster, space guy. Okay, where are they? Inside a space station? They're
Yeah.
looking.
Oh, there could be yeah, there because you can see the curvature of the Earth back there.
All right. Anybody want to do this, or you want me to read it?
Go ahead.
Is that Brewster talking? That asteroid's getting closer to
No,
Earth. Got to
Brewster is
send.
the guy on the right.
Oh, he's the handsome young. Of course he is. Got to send out an alert. Asteroid coming. And Brewster says, "Not yet." He's looking through the telescope, just so small and far away. It's not an immediate threat. Let's not frighten people. Come on. And a scientist with him says, "You had the telescope backwards, Brewster. Try it now." Oh, I see. That's much better, he says. And then kaboom, kasplat. And they say, "Okay, let's notify Earth." So apparently they're not on it. They're orbiting, I guess. Okay. Where do you get Brewster rocket? Where do you
just
get trilobites?
randomly on internet
I've never
sites.
seen him before. He's great. My kind of
It
hero. Trilobites.
it's a syndicated strip that used to be in the LA Times years ago.
Oh,
Okay.
We all know about trilobites. We've seen these suckers. Were they insects? Were they horseshoe crabs? What the heck were they? Were underwater, and they find the fossils. And it says here, I could never remember how many trilobites there are in a gigabyte. They have yet to find a fossil of a gigabyte, but I bet you it's bigger, huge and disc shaped. Here you go. Thought provoker. Science says we're all made of stardust, which sounds poetic till you realize it means you're basically space dandruff and belly button lint.
oh God.
And this is some sort of a time machine institute of time measurement. And they're looking at it, and the scientist says to the lady next to him, that one always runs fast, summer vacation. Isn't that true? When you grew up, didn't you think your time of
Oh yeah.
vacation in summer was the same length as the time you spent in school because it was so much fun?
You
And
know,
they do.
after I grew up and started my career, I was always looking forward to summer because it was in the back of my mind, I had the feeling of summer break or summer vacation. It never happened when you're working, of course, but
Oh,
it
of
still had
course.
that feeling as we're getting close to it.
Well,
And
my parents,
they've screwed up here. It should be daylight saving time, not savings.
Yeah.
oh, you're right. We're trying to get rid of it. Let's see. We're due for fall back, so that's
I'll
not
tell you
what it is.
another.
Yeah.
I'll tell you another aside here. Back when I went to sea, I used to always get seasick, and I never saw time go so slow as when you're
Yeah.
seasick.
we-
I looked at my watch and it was 12 o'clock, and then what
Oh,
seemed like an eternity, and I looked back and it was 12:02. And I
Yeah.
went, oh my God.
see, that's time goes very slow when you're bored. And so boredom, you have to look on boredom as a gift because time goes so slowly, it extends your life.
Yeah.
It slows it down. So
Yeah,
you
you're
really should enjoy boredom.
well. Then your summer should have been gone by real fast as a kid. Here is the underwater otter. It's a strange mammal that says he needs those parts for his spaceship since he's going to outer space. A couple of PVC pipes. Now, this is a futuristic rolling android robot that says, as he's picking up stuff, one small rock for man, one giant waste of time for robot kind. And they're looking at him from the control room. You know, he does this with every rock. And he says, back, Houston, you are my problem. Definitely beginning of the end of mankind with that cartoon. The AI bots about to realize they've had enough. Virus versus retrovirus, or Afrovirus, if you will.
No,
And
this is back to the 60s and 70s.
Retrovirus, okay, retro.
and this picture of a kind of virus, these are called phages,
Yeah,
and they actually prey on bacteria. And some people around the world are developing strains of them to use just like antibiotics to
right.
fight infections
They'll get in there and
Really?
inject their DNA to kill the virus
or bacteria.
or bacteria, excuse
Yeah.
me.
Some little one-celled pathogens have a tail, but I don't think any of them are built like spiders, are they? They don't have little
Oh,
legs.
that's actually the structure of a real virus.
Really? Do they
Yeah.
walk?
No,
They don't
it's
walk.
called a
They just,
phage. They
Yeah.
kind of use those to attach to the bacteria.
and have you heard about the ones with the corkscrew tails? They have a little engine-like
All
device.
kinds of microbes have those. Yeah.
Yeah, that's all evolutionary. We are on the rocks of Mars. Are we starting? I think we
it,
are. There it is.
it's really faded out.
Still, it looks like life to me.
Yeah.
Probably the way it really is throughout the universe, mostly microbes.
Yeah.
We lucked out here and became.
Yeah, a lot of this I didn't understand. I'm just gonna roll with it and see what you guys do with this.
Well, help me in
There it
asking
is.
questions, Tim, for
Is
crying
this
out.
better?
That's
Yeah.
much
Oh, way
better.
better. Yeah.
Yeah, okay, good. This is a photograph. They discovered this stuff back in 24, about a year ago. And apparently these patterns here, they call them leopard spots, but these white spots in here, apparently those are mineral deposits left by the left by the metabolic processes of bacteria on Earth. And so, of course, they want to make the same judgment of the little laboratory that's carried on the rover is insufficient to definitively show that these are signs of past life, but it's very suggestive. So they need to get the sample back to Earth somehow to settle this question. But to my mind, it's 80 or 90% settled. You know, there's just too much circumstantial evidence for these.
This is another case where they've found signs like this that can be produced both by living organisms and by chemistry, by, you know,
By
Natural
inorganic
process.
chemistry.
inorganic activity. But the chemistry processes require things like heat or strong acids, and they don't see evidence that that has happened to the rocks surrounding where this is.
Remember the blueberries they found
Yeah.
on Mars?
Those are definitely just
Water,
geological
produced by
processes.
water, right?
Yeah.
What
So-
we were just
so-
looking at.
With that rock, was it like in a riverbed? I know it was in this
Yeah.
crater.
Yeah.
Yeah, it's in Jezero crater.
Okay.
Okay.
Okay, those are the
Poppy
spots. Okay.
Uh-huh.
Poppy seeds, I didn't get that.
Those are the little dark ones.
Yeah.
Means there's opioids on Mars.
Now, are they also mineral deposits or?
Yes.
Yeah.
Everything
Okay.
you're looking at here is a rock broken open.
Oh,
Exposed to the
okay,
surface.
okay.
Well,
That's maybe what I missed.
I've seen granite on our soil looks like that.
Yeah.
Mm,
And we have life on Earth.
yeah.
So
Granite is much more crystalline in appearance.
That's true. It's a mixture, isn't it? It's
Maybe it's a kitchen counter.
a
Yeah.
mosaic.
Well,
What are the-
marble, marble looks like this, and some marbles have that pattern because of organic stuff.
What does the dotted line rectangle at the bottom mean?
I don't know.
Okay.
That might be where they took a sample from.
Oh, okay. So the jury's still out till we get it back here.
Yeah.
Now, this rover can take a sample, does it literally have like a little drill?
Yeah.
Yes.
Okay, and so and this is the one before the show we were talking about getting it back is going to be a little difficult.
Yeah, this
Right.
is Percy.
Is there any kind of a age with the sample? Will it expire after a certain time, or is it just no?
No.
Okay.
No.
I think the sample is several billion years old now.
Yeah.
Oh, it's
Not gonna
probably
change in
expired.
our lifetime.
So this is a picture of the Perseverance rover.
Yeah.
This is a selfie.
How? I don't see a connection.
Yeah, it's put together with a lot of it's a mosaic of a lot of individual frames.
Well, is your godson's little helicopter just sitting out there on the Martian plain, or did it get underneath its mothership again?
At this time, it was off doing something else. It had not killed itself yet.
Oh, okay. So it's
But it's just sitting on the ground now. It's become, like you said, a weather station.
Yeah. And this one has a laboratory on board that does chemical analysis, and that's where they get the chemical analysis from.
wow.
And it has an arm that it stretches out that has a camera on the end, and that's how it took this picture. But then they take multiple pictures as they move the arm around, and then they leave out the image of the arm and put in the images that would have been in the background of it to build this image.
Okay, yeah, that's how they did it. All right. Now, like they've done in the past with software updates, is it possible that software updates will also be able to upgrade the testing station?
No, it's more just the instruments that they have on there.
Yeah.
It's limited. Okay.
Yeah.
Well, getting it back, that'll be a trick. Maybe Musk will go up and get it.
Oh, no,
But
don't count on him for anything.
Mr. President's Perseverance is the lander that's supposed to be getting the samples, right? None
Yes.
of the others.
Yeah. Oh, it's the one that's making the samples I thought it was leaving them behind at sites that then
It is. It
a
is.
new rover would go up and go to those sites and dig around in the sand and hope to find it.
Yeah, but they gave up on that program because it was getting more and more expensive. And especially once the helicopter worked, they said, "Wait a minute, we gotta rethink this." And they thought it'd be much better now and easier to have a helicopter that goes and picks up the samples.
Yeah.
Really? Another one?
Yeah.
Wow.
Huh. But
Interesting.
how are they going to get it off the surface?
The helicopter will go
Another
pick it
problem.
up
Yeah.
and then take it to the lander that brought the helicopter there, which then has a return capsule thing.
Oh,
And one of the plans was to just shoot it up into Mars orbit and then have a future mission that comes and grabs it there.
yeah, yeah, that makes sense.
But are they moving Perseverance? Because
Yeah.
Curiosity and some of their other landers went all over Mars. They had
Yeah.
tracks here and there and flat land.
Yeah, you can see tread marks all over this picture.
Yeah.
But isn't it
That's why
still
they call it
inside?
a rover.
It's not still inside that crater they landed in?
Yes.
That's
Yeah.
a very big crater.
Oh, is it?
And the rock they're talking about is right in the center.
You can see there's a drill hole in that rock, that big
Yep.
white rock.
Yep.
Wow.
I don't know if this is the one they're talking about, but it's that area.
No, they actually said that it was
Okay.
almost in the center. So
Okay.
that would be the one.
Yeah, right there.
Yep.
Although there looks like there's something there too.
Well, that's the hole.
That's the hole.
Yeah.
And this is debris around it. So this must be a glint, a glory from the sun.
Yeah.
Yeah, because the shadow looks like it's all behind. So this is looking down as if you were the sun.
Well, a paleontology question. Microbes, do they make fossils?
Sure. Some of the earliest signs of life are called stromatolites,
Oh,
and
yeah.
they're fossil blue-green algae.
And we know they were a living being
Yeah.
before. It was not just a little piece of mineral or something.
They're there now and they're still living.
Yeah. Well, some of them are, yeah.
I'm talking about the ancients that they find along with the dinosaur bones.
Well, these date back way further. These are some of the earliest, stromatolites are some of the earliest signs of life.
Yeah.
Okay. What is this?
Yeah, this is the one I didn't get.
This is their scale for how confident they are that something is biological.
Okay. Okay.
So you start down here with detection of a signal known to result from biological activity. It doesn't mean exclusively biological activity. So there could be other things that produce it too.
Okay.
And so that's the detection of the biologic signal. Then level 2 is contamination is ruled out. And I guess they've ruled that out.
From us.
Right.
Yeah.
Okay.
And they're at stage 3.
I think this one is at level 2, but they're working to get level 3.
Yeah, because here, abiotic false positive discrimination. So that's level 3 and 4, and that's where we're at now. So they need to ship it back for us to get past level 2 to level 3.
Okay.
And then this will be done in the lab. All known non-biological sources of signal shown to be implausible in that environment. Alternative hypotheses eliminated, additional independent signal from biology detected. Future observations that rule out alternative hypotheses proposed after original announcement.
Hmm.
And then independent follow-up observations of predicted biological behavior from the environment. And the word independent is one of the key things of science. Science is a process. Science is not a big book full of answers. It's a process of how to get the answers. And so the thing that critics of science say is, well, scientists can be bought with money. And that's a little offensive, actually a lot offensive. But into the process of peer review is independent, even hostile independent verification. And that's how science works, by people picking holes in it. So it's not one person that says, no, this is it. It's a process, and it's independent verification.
Right. And that's the thing a lot of the like the creationists and the anti-evolutionists don't get. It's they think it's just a book like they have and that what's written there is right. And
Right.
it's not.
No, it evolves.
It can
So
be
in
proved
science,
wrong at any
go
moment.
ahead. So science never has to face the question of who do you believe? It's not a question of someone convinced. It's not a debate.
Now, Chuck, you mentioned before that there was evidence that wasn't there that they were expecting if this was mineral deposits left behind.
Right.
Is there any other possible theory that they have that could explain this other than it was signs of possible life?
Well, it could be the geological process, but they with the instruments they have on the rover, they did not see any signs of the geological processes. But that doesn't mean they wouldn't find signs of it if they were able to do better analysis.
Okay.
Well, how stunning would it be on our culture if they found out it was life?
Yeah.
Not like they're monsters or it's H.G. Wells, is it?
I was kind of hoping that they'd find like an in and out wrapper up there.
Yeah.
If
I'm
they
sure you
find
could
that,
find
if they find that, we know it's contamination.
Yeah.
Yeah.
I'm sure you can find somebody though that claims that one of the pictures shows that. You know, they have all
Yeah.
kinds of
Yeah, exactly. Exactly.
Okay, to the night sky we go.
Okay. Now this is the constellation of Corona Borealis. And it's at 9 o'clock in the evening. It doesn't matter which evening, it's about the same. So in the talking points, I call it our bearded, this is Iota Corona Borealis. And that star is the thing that's in the red cursor. And its bearded friend are high in the evening sky. 100 or more years ago, they referred to comets as bearded stars. Because they had no idea what they really were, just the dirty snowball. But this comet, I don't know, it's a Polish name.
we need Tom Whittemore here to
Yeah,
Yeah.
Tom Whittemore would have it.
Yeah. So anyway, fifth magnitude, Iota Borealis. The comet Wirkus is right there. This is the path.
Oh God.
Yeah.
Sorry about that.
I love how you torture Chuck.
Yeah.
This is
So
such a horrible map.
This little symbol right there is a Greek letter I, iota. It should have a dot at the top. That's the star. This is the 15th of October, which is today. So it's very, very close to iota
September. Yeah.
in that picture. And
September.
Yeah.
yeah, and this is a picture of that comet near iota. This was taken on August 28th. It's much closer than that now. And
Well, it shouldn't be near Iota either.
oh, this is near Lambda Corona
Okay,
Borealis, excuse me. But I was going to point out that the comet is not going this way. The tail is not necessarily a sweepback from the path of the comet. It's no matter where the sun is, this is blown back by the sun. So the comet could be moving this way and the tail with it. I don't know which way the comet actually is moving in this picture. But if we go back to Chuck's picture, if I can find the go back button, that would be, let's see, September. Oh, that was in August, so it's way up here somewhere. It's out of this picture. Okay, can't help you.
Boy, if the Corona Borealis goes, I wonder if they have a wide enough camera that could get both that and the comet.
I think it'll be gone by the time that Corona Borealis goes off. I think it was predicted to go off in November, wasn't that it?
Yeah,
That's what a lot of people say.
Somebody who studied the orbit of the system that produces this says it'll be either November 10th of this year or June 25th of next year.
Yeah.
So making a prediction like that really sets you up for absolute failure.
Pretty gutsy.
Yeah.
Did I miss the star in this picture?
Virtuos. I wonder if, yeah, Tom would probably say virtuos.
Yeah.
Oh,
Okay. Now this one, there's a number of comets in the sky. This one, we're going to take a little brief tour away from comets and go to the Owl cluster. Not the Owl Nebula, which is a planetary nebula, but it's in the same region. No, it's up near the Big Dipper.
Yeah.
The Owl Nebula is. This is the Owl cluster, and it's here in the disguise W of Cassiopeia. If you look at the sky, the only stars you see out here from my backyard is the W, so it's less confusing.
Yeah.
And
That's
this is the
exactly
Owl
right.
cluster. It's near the double cluster right here.
Tim has a great star hop for finding this NGC.
Yeah,
457.
you know what I do, Jerry, is I actually use the star that's opposite that middle star of the W from up above now, and that star up above in the figure. No, the other direction. Upper left. Okay, now in the middle. So the middle starts at the end of that line. Go up on the line to the one star.
On the left, on the left.
Yeah, on the left.
Follow your constellation line to the left from Gamma.
Yeah, from Gamma. Just go up that line.
The one to the left.
The end straight up to the left. That one. Okay, if you take that star and then shoot it through the middle gamma, and then you make a right angle to the star that's to the left of it, where
Rookbot.
M103 is.
Yeah.
You just make a right angle, coming down to where 457 is, and
Right
then
there.
you make a right angle, and that's a really sure star hop, or just make that right angle.
Uh-huh.
Yeah,
Going
just
left.
make a right triangle with Rookba and Gamma, Navi.
Yeah, exactly.
Oh, I see. Yeah, like this.
Like that. Yeah, you just make a right triangle right there. But I use that star above, which sometimes is very, very faint, and you just draw a line down and and turn left with a right triangle, and it's really at that corner of
Well, I can remember the right triangle one.
yeah, the right triangle that's the easiest. Somebody says, "Why are you using the star? Just make a right triangle." I went, "Oh,
Yeah.
that makes sense." But it's a really fast, easy star hop. And when people look up there, it never ceases to amaze me that people say, "Yeah, I can see it." And you go, "No, you can't. There's nothing there that the human eye can't see that."
Okay, can we see the blow up of an owl? Does it
Oh
look
yeah.
like it?
Oh yeah.
Oh, there it is. Okay.
Sure got a funny looking beak.
Yeah. Now, these lines do not occur in the sky.
Yeah.
It'd be great if they did.
This is
It's
not
interesting that the eye colors are kind of a blue and yellow, but this is only showing the reddish colors.
Yeah. When people process these pictures, it's very hard to control the star colors. And when you do there's several stages in there. One is a linear transformation, and the other one is called curves, which is a nonlinear transformation. And the nonlinear, where you bring up the dark stuff to a brighter level, but you don't make the brighter stuff any brighter. And this usually washes out colors. You have to go back and specifically resaturate colors if you want them to preserve. They didn't do that in this picture.
I didn't know that, Jerry.
So this
These
is
astrophotographers do some unbelievable stuff. That's more like what you see.
Yeah, this is a wide angle picture of the owl cluster, the wings, the body. And this is another cluster down here that
Rich Milky
is
Way.
NGC 436, showing them both in the same frame.
This is a good Halloween object. It's well placed around Halloween.
This is good stuff. You're right, Chuck. This is one that I don't know if we're going to get a chance. Well, next week. This week, Friday, if it's clear.
Is that the 31st?
No, it's the Westmont.
Westmont.
Oh, Westmont. Okay.
You
Okay.
may or may not have, there's supposed to be some rain coming, so who knows?
Yeah.
Yes, I was out in the backyard last night hoping for clarity, but it was just, and it was hazy, but everything was soaking wet in my backyard.
Oh,
Heavy
okay.
dew.
Just an aside, Jerry, you sent out a November newsletter article, but is it really for this next newsletter, which is October?
Yeah, it's for the thing due October 20.
October 20, not September 20.
No, it's the thing due September 20.
Okay, okay.
So
So it's
that's the
my October
October letter.
newsletter. Okay, gotcha.
Oh, change that, scratch that out and put it in.
Okay, you
Put in
got it.
October, yeah.
Yeah,
Well,
also people, it's great when you get kids to look at this because they do not see the owl. They'll see bat rays, they'll see cars, they see jets, they see
Yeah,
all kinds of stuff.
it's an F-18 on Afterburner if you flip it around.
One of the and it's also known as the ET cluster. And a lot of the young kids have never seen the movie ET, but that's also a really, really good one
yeah,
because
kids, it depends on a kid's background, what he's seen.
Yeah.
yeah,
We're probably
yeah.
not ever looked at an owl in the face.
Yeah, and it's amazing what all the stuff they say. And these asterisms, they're given these names, but it doesn't mean they have to stick. People can make up
No,
whatever they want them to look like.
oh, they change all the time, in my
Yeah.
view. Okay, now Friday morning, um, this coming Friday, the 19th, I think it is,
Yep.
just before sunrise, you have a triple conjunction with the moon, Venus, and Regulus right in here. I think that's
Yeah.
this thing here is the letter Alpha for Alpha Leo.
Oh,
So
there's
Regulus
the
gets
line.
around. That was the
I couldn't
star
make it
that
out.
was. What's that?
I couldn't make out the line, and now I see the algebra and Regulus. Now I get there's
Yeah.
the main and the
It's
head.
more like a little triangle.
Yeah.
Oh, this thing in here, triangle?
Yeah.
Yeah, it depends on where you are, apparently, from the write-up they put in there. In some places, it'll look like a line coming up, straight line. Not here in the West. And in Europe, I guess they're going to get an occultation of, in Northern Europe, they're going to get an occultation of Regulus by the moon or Venus, but one of them was in the write-up.
And a nice little thin crescent. That'll be pretty.
Yeah.
Tom Whittemore will certainly be up to see that.
Yeah, the moon passes in front of Venus from Northern Europe, Greenland, and far north Canada.
That'll be
For us.
spectacular.
Oh, Greenland.
Well,
Yeah, with Venus being so bright, that'll be a spectacular sight.
yeah.
Yeah.
There were something that people did back when I first started in amateur astronomy in the 60s. They would set up a photomultiplier tube and they would measure when a star went behind the moon or the moon went in front of the star, actually. They would measure the light curve as it disappeared, and you could see the diffraction interference as the star was cut off by the knife edge of the moon.
And they still do that to discover double stars along the path that the moon follows.
Speaking of doubles, is Regulus the double or is it algebra?
Algebra is the famous double.
Okay.
Well, here it's listed as gamma 1 and gamma 2.
Yeah.
Okay.
Yeah, Gamma Leonis.
Gamma Leonis.
I think there used to be a sign-off. One of our members would sign off his emails with, if we can send man to the moon, why can't I split Gamma Leonis?"
Tell him he could from the moon.
Yeah.
Okay, this is the famous 3-eye atlas. And this picture, taken by the International Gemini Observatory, which has a telescope in the north and in the south. Shows the development of a tail. At first, when it came in, it was believed to be by a very few sensationalists to be a candidate for a space probe, which is very irritating, but I guess a possibility. But people should not mix possibilities with probabilities. We live by probabilities. We do politics by possibilities. So anyway, this is the start of 3I. It's coming in. This is a picture taken by a 8-meter wide mirror, so it's a very big telescope.
Whoa.
And it's starting to show a fuzzy coma and a tail. Now they are getting a lot of pictures of this and spectral readings that show that the comet, it seems to be turning green.
So they're getting finally the dicarbon, the C2.
Yes. So a lot of comets turn green, and the
So not oxygen, huh?
No, not in this case.
it's what Chuck is calling dicarbon, which is C2, which is not terribly stable. In a lab, it was interesting to read that when you produce dicarbon in a lab, it almost immediately loses its green color because it's at atmospheric pressure. And so it's got a lot of other dicarbon around to collide with and split it or combine with it to produce other compounds. But in space, this is very diffuse. And so you can tell how dense the comet is by how far down the tail the green persists before it reacts with its neighbors and transitions to non-green emission. So the green glow is dicarbon, but it's also, let's see, in the lab, researchers used ultraviolet lasers, carbon chloride, and I've always called this carbon tetrachloride, but they don't call that in this article. So
Now, Jerry, I missed what you were saying. When they test that green, when the green disappears, it indicates the distance?
Well, no, you can
Size of the comet.
Oh, the size.
Density, kind of.
Okay.
It indicates the density of the dicarbon, which in some cases you could infer as then the size of the comet, how much it's putting out.
Right.
Okay. And this indicates, and there's a clear right there where the green fades to the white.
Yeah.
Yes. This is a comet Lovejoy from 2014. It has a very clear and definite green, but the green is not in the tail. And that's because the thing that produces the green, carbon tetrachloride and dicarbon, is unstable. And they combine with each other to lose that compound, form something else that doesn't make green if it's dense enough. So on Earth, it's very difficult to get that green color because you're measuring molecules that are surrounded by an Avogadro numbers of other like brothers, and they all interact very quickly to lose that compound. It's an unstable compound. But in space, it's mostly vacuum around here, so the stuff lasts longer. So if it's really vacuous and it's just putting out a little of it, you'll get a lot of green down the tail.
Boy, that's a neat shot.
Yeah.
From Lovejoy, yeah.
And the carbon tetrachloride, I don't think they're inferring was in the comet. That's just what they used in the lab to make the dicarbon.
That's right.
Yeah.
And I think that they don't call it carbon tetrachloride there when they do that. They called it, is it carbon chloride? But it was a very dangerous cleaning agent here on Earth that you
for dry cleaning, yeah.
Yeah, for dry cleaning. Lethal as hell.
But
oh, really? Wow.
This baby is only a visitor, will never be seen again.
That's right.
Yes, that's right. It's on a hyperbolic trajectory.
It's doing a drive-by shooting.
Yeah.
That's interesting.
Okay, so
now this is not the one that comes later, the Swan.
No, this is not Comet Swan.
Okay.
This is Comet 3I Atlas.
Okay.
from deep space. Depending on how you count it, it's the third or fourth interloper.
Well, why do you suppose Oumuamua didn't do a tail and think it's classified as a comet?
It was classified as a comet, but it was mostly hydrogen ice.
Didn't
Huh.
have didn't have anything to evaporate as it passed.
It did, but it wasn't stuff that glows like this,
Oh,
fluoresces easily.
Okay, so anyway, now I sent out, this is the third iteration of this picture. The previous one had some color shots of things in space, but I couldn't find any legend or that explained it. So other than just a pretty picture, it didn't mean anything. So I dissed it and sent out this copy instead. And this shows nickel production rates versus heliocentric distance comparison with solar system and interstellar comets. This comet coming in from interstellar space is producing this, the square brackets around quantities in physics means that the units are numbers. And that's what it means here, atoms per second. So it's a flux. And so this is the number of nickel atoms, log of the number of nickel atoms. And so this is very quickly going up. So each one of these changes of a unit is a power of 10. So 21 to 22, that's 10 times. So this is pumping out a lot of nickel, but it's not pumping out any iron, and that's unusual.
Tim, you want to tell me what he just said?
Hell no.
Well, it kind of. Go ahead.
It's way above my head. But it's just, I mean, when I'm looking at that log and that number that Jerry said it's in brackets, it right there, I started thinking, okay, so there's a fast rise, but what do you mean by a fast rise there, Jerry? From 21.5 to 22.
That's a factor of 10.
It's a factor of 10.
From 21 to 22. From 22 to 23 is a factor of 100. So this is really pumping out nickel. And this is the number of nickel they're getting, but there's no iron coming out, and that's unusual. There are comets that are nickel iron comet. And
Are they producing this?
No, the nickel is part of the makeup of the comet, and then it's being spewed out as the comet vaporizes, as the ices turn to gas. The suspended nickel and whatever rock and stuff that's inside that is spewed out into the tail.
Oh, so this represents the spewing out. So
Yeah.
okay. I totally missed that.
Okay.
And the fact that it's mostly nickel and not much iron kind of implies this thing came from an environment near where you might have had neutron stars collide rather than just a type 1A supernova like makes the nickel and iron in our system.
Well, what we really want to know is it older than dirt?
It's way older than dirt.
Yeah.
Did I miss what you said the colors meant?
Those are different comets.
Yeah, these are all different comets.
Oh, I see.
This is comet Hyakutake.
Hyakutake, yeah.
This is Borisov. This is another Borisov. This is Comet Workman.
Okay,
and there's other ones in here. The Oort cloud comets are these orange triangles. So these are the compositions of the debris that's in the coma of other comets. This is the distance from the sun. Here we are at 1 AU. This is half an AU, so this is in about Venus. This is out here.
Okay.
It's going to come close to Mars. So as it's coming in, it's heating up, and we're getting this crap out of it. Getting these materials out of it.
And it's producing the nickel much earlier than some of those other comets.
Right. So the nickel is not being heated to the point where it's volatilizing itself. It's subliming. It's apparently in ices.
So if there were what's missing is the iron?
Yeah,
right,
the iron and nickel are associated.
So if the iron were present, it wouldn't sublime that fast, I bet.
No, no. It just means that this is showing you how fast it's producing nickel.
Right.
Okay.
It doesn't say anything about iron for any of these comets.
Okay.
Except that
But-
iron is missing.
Yeah, in the write-up it mentions that iron is missing, so that makes this even weirder.
Yeah.
Okay.
Now, these are the boiling or sublimation temperature. These are surface temperatures of different compounds. CO, carbon monoxide.
Oh, see, that's invisible on the display here.
Oh, okay.
The headings for the different compounds.
Is nickel above or below iron on the periodic table?
Nickel is denser.
So it never gets manufactured in a normal star then, does it?
It can briefly
Is this
in a massive star that makes iron, and in the explosion of a Type 1a supernova.
Okay.
so can you see these things down
Yeah.
here?
Yeah, now they show.
So this is carbon monoxide at 25 Kelvin. So room temperature here is 300 Kelvin. So water, you get water coming off at 150 K, CO2 at 90 K, ammonia at 78 K. Is ammonia NH4?
Oh, I don't remember.
Okay,
But that's probably ammonia there.
yeah. So this is your chart of socially acceptable comets, and this guy doesn't fit.
Yeah.
I'm wondering about the definition of comet. My understanding is they all used to come from way out, the Oort cloud.
No.
This came from beyond that.
I know, so it almost needs another name, doesn't it? Asteroids are inside between, Mars and Jupiter, or into Jupiter's orbit.
Well, but see, some asteroids show cometary activity, so the whole thing's fuzzy.
Yeah.
So we've had asteroids with a tail.
Yes.
I don't recall ever seeing one.
We have talked about this before. Yes, there are asteroids in the asteroid belt that show cometary activity. There are things called centaurs that orbit that most of the time look like an asteroid, but when they get close to the sun, they have cometary activity. It
Oh,
just means it has volatile materials in it, and that's a whole continuum. So
okay.
there's
There
no
are-
sharp
there-
definition.
There are moons around Jupiter and Saturn that have tails.
Yeah.
Oh, wow. Yeah, no, I missed this. Yeah, that's good.
Mercury has a tail.
Yeah.
Mercury does?
Yeah.
Yeah,
Oh, wow.
But it's sodium atoms.
yeah, it's sodium atoms, but it's a tail.
Wow.
Is it possible for an asteroid that is cometary with a tail to go right back into the asteroid belt?
Well, it can show the activity while it's still in the asteroid belt.
Yeah,
Yeah.
It doesn't have to come in close to the sun necessarily. It just needs to have a spot that gets heated up.
yeah.
But it's not in the circular orbit of the belt. It's got its own.
Yes.
No,
Yeah.
it's in a
It is.
hyperbolic orbit.
Oh, okay.
It's like Chuck says, it's a drive-by shooter.
For this comet,
Drive-by.
yes. But the active ones in the asteroid belt are in the same orbits as those other asteroids.
Yeah.
They just have more volatile materials in them.
And some of them have been there for a very long time and have lost almost all, if not all, of their volatile materials.
Well, I
Ah.
just have a feeling there are definitive definitions, if you don't mind my double speak, of all these things. Asteroid is something that doesn't go into the sun or whatever, doesn't come back regularly.
No,
stays
no,
in
no.
the sun.
They're near Earth asteroids. They're near sun asteroids, like the one that produces the Geminid meteor shower.
But they only become a comet when they have a tail, when they release stuff.
You should
Oh.
take your chart that has these categories on it and pour water on it and
Yeah.
let them all blur together.
Everything's fuzzy.
Yeah.
And one last question here. Atlas, that's what this is. The blue is. Is this in the talking points? This is not the one that you were referring to, coming from a completely different star system.
Yes, it
this
is.
Oh,
3i
this is the
Atlas.
one.
This is the interstellar comet that Avi Loeb thinks is a probe.
And
And the
so
green
it's all,
one there, Borisov, was one of the previous ones that was also interstellar.
and this is why the absence of iron is so interesting, because it's from another star system. It's going to tell them some information there.
Yeah.
Yes, it's also loaded with cyanide.
Whoa.
Which we see in Halley's comet too. That was the big thing in 1910
Yeah,
when it
so
was
that's
coming
one.
by,
Yeah.
they detected cyanide in its tail, and we were going to pass through the tail of the comet potentially.
So
And so
people wanted,
there were people selling gas masks.
yeah, exactly. I was going to just say that would make sense.
Cyanide,
Quick way to
cyanide's
make a buck.
cyanide's not an element, is it?
No, it's a
No,
compound.
It's a
carbon and
compound.
nitrogen.
Oh, no kidding. Be damned. One of the most toxic poisons there are.
Yep. There's Comet Lovejoy again with its green head.
That's a neat picture.
Yeah.
Is
Now
there
this
any way
one,
you can lump this together, Mr. President, and go to that one coming out from behind the sun?
I think we just did.
Yeah, that's this one.
Yeah, this is the one that surprised everybody. It disappeared, and then all of a sudden it came out from behind the sun. Everybody thought it would burn up and melt.
Oh, it's
So
okay.
this
This is
is
not
Comet
Atlas.
Swan. It does have a greenish hue to it, but you got to be careful of that because all these pictures, especially made by amateurs, they're after a pretty picture, and these are all false colors. So if you see green, you need a spectrum of it to see if the lines are really produced by something that would give it a green color, other than someone hovering over their PixInsight software.
Is it possible that the asteroid that killed the dinosaurs might have been a comet?
Well, it left a whole lot of iridium.
Which they don't find on comets?
No, they find it on comets, but this was a lot. And the one that's most likely to be a comet is the Tunguska impactor because it didn't leave a big crater. It detonated in the upper atmosphere,
Yeah,
and they didn't find a lot of nickel iron left behind by it.
flattened every tree within 300 miles.
Yeah.
Amazing. Wow.
Well, the Planetary Defense System, which is a real thing and is funded, is working on the problem of big objects like the KT asteroid that hit, trying to find it and figure a way to deflect it. But the issue is not so much asteroids, because the asteroids in our system, we're learning those, at least the bigger ones, and we know that they're in known orbits. So we have a chance with those, because if one of them is going to hit Earth, we can pretty much determine its risk factor decades in advance, which was something we need. But the big risk is something coming in from deep space, from the Oort cloud, or like 3I that's coming in from an interstellar. It comes in and has really no warning. You know, in a few months, it's either hit or missed. And so the big problem is, how do you defend against something like 3I if it were heading toward Earth?
Yeah.
Don't we
The
have
odds
two
are
dates?
very, very strong. The odds are very, very strong that it would miss us. Go ahead.
Aren't there two dates in mind, 29 and 35?
That's for Apophis.
Oh, just one. One.
And there's no danger of it
That's
hitting.
Yeah, that's an asteroid, not a comet coming in from deep space.
Yeah, well, that's what I was talking about. What's the one that's going to be closer to the moon or go in between us and the moon?
That's that C2024C4 or something like that. Yeah.
I forgot the name of that.
Yeah.
There's a 97.5% chance it's going to miss the Earth and the moon.
That's good.
I'd place a bet on that.
Yeah.
Okay.
Did we run through all the talking points?
No,
Not
we
yet.
got two more to go.
Oh, okay.
This is the 19th at 10 p.m. This shows the
10 o'clock Friday night.
here and the lower end of the W of Cassiopeia.
And hey, and the owl is listed as the ET cluster up there at the top.
There you go. There's ET.
Oh yeah. Oh yeah. I didn't notice that. The Cork cluster. I've never seen that.
Yeah.
Oh, that's the dumbbell, the mini dumbbell,
Oh yeah. Okay.
the little dumbbell.
Oh,
And
I've never
there's-
looked for that.
Pasmino's cluster there. And I got to turn these labels on more often. And there's a planetary nebula right there, but no name associated with it. This one, however, this cluster of things, this is the Heart and Soul Nebula in this region.
6,000 light years away.
And this is a false color picture. They're all false colors. So this is, let's see, was this a JWST or? It's a WISE, Wide Field Infrared Survey. So it's in the infrared, and it's done here at, oh, that's a degrees. Doesn't say the wavelength.
It does. It says green and red are 12 and 22 microns respectively.
Oh, up in the, yeah, you're right. Go ahead.
Blue and cyan, 3.4 and 4.6.
Where I'm missing it.
Yeah.
It's in the paragraph.
Yeah, it's in the points.
Oh, okay.
The blue and cyan are at mid wavelength, and which is reflected light by stars, and green and red light 12 and 22, which is mostly light from warm dust. That is, it's emitted light from the dust. And the other, or the shorter wavelength, is reflected from dust. So
or just produced, because the stars are showing real blue.
Yeah. Yeah.
And there's a nice galaxy right in the middle at the bottom there.
Yeah.
Well, only one of those is supposed to be shaped like a heart. Which
So
one is it?
this one looks like, there's valves up there, and this is
Oh,
the part, the lower chambers and the upper chamber and the aorta. And
Well,
this
one looks like a strawberry.
I think that name is used somewhere else.
Oh, I'll bet. I'll imagine everything's up there.
Now, these are fairly faint. You won't see these easily from Santa Barbara with our small amateur scopes.
But even though there's false colors, do the colors represent something about what they're colored, what they're coloring, what those areas are?
That's what science does. It's amateurs want a pretty picture as your eye would see it, which is nonsense. And scientists want information, so they code color to be related to what wavelength it is. And the James Webb stuff, they have something like 20 filters on board, and each one is a certain different, they're color coded. And all these things, they use a whole bunch of hues and colors, tan and blue and purple and mauve and stuff. And you'd need a set of color cards to hold up to a picture. And then your video screen probably wouldn't be reproducing the way that the data is actually represented. So it's devil take the hindmost in that case.
But a spectrograph, or even a prism for that matter, gives you certain elements or compounds in space, just because you pointed it out, what oxygen looked like, what nitrogen is colored.
Yes.
Those are natural.
This is a big nebulosity. The picture is 5 by 4 degrees. So that is, the moon is half a degree. So this is
bigger than the moon.
8 by 10 full moons.
Wow. And yet you need a scope to see it.
Well, you need a scope to see tiny parts of it, yeah.
Jerry, what is the kind of electric looking whitish green around these? That's shock waves?
I don't know what you mean.
The greenish.
This?
Yeah. They're saying blue and cyan are infrared wavelengths showing light from stars. So that's kind of reflection.
Yeah.
And then the green and the red is emission from dust.
Yeah.
Or not green and red.
The structure this has
green and red
is dust. And somewhere there's a hot young star in here that is or group of them that is producing solar wind that is pushing these things away. And where the dust is less dense, it responds better to that pushing, and so it moves away. But where it's denser, then that region resists the being pushed away, and so you get these nodules in here.
Yeah, that's what I was wondering what they were.
Yeah, well, they could eventually become protoplanetary disks.
Okay.
And the bright part up there, of course, is stars there illuminating the dust.
Okay.
Yeah. And here's a nodule, very, very strong one.
Mm-hmm.
It's getting blown away from probably something down here, and it's very dense, so otherwise it would be blown away. So this is a star forming region that has formed some stars, and those stars are putting out a solar wind or stellar wind, and that's blowing the rest of the dust away. Eventually, this whole complex will become an open cluster with no dust in it.
Well, I got to tell you, gentlemen, I wish we could play music because there's a song for this. You know that? You ever heard of it? Heart and soul, I fell
yeah,
in love
Oh,
with you.
yeah. Yeah.
We all did it with the piano, remember? Dun,
Yeah.
dun,
Yeah.
dun, 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 dun. That was Heart and Soul. Well, we don't need those other two guys. If you didn't have them, of course, it's a little friendlier and nicer, and everybody chomping at the bit. But let's do it again. We just never get enough of this. That'll wrap up, I guess, our SBAU Astro Hour for this week. Number 239, ladies and gentlemen, airs next Monday, September 22nd. Dr. Filipenko of UC Berkeley is our guest speaker in Fleischmann Auditorium Friday, October 3rd. Meanwhile, we say farewell using our astronomical Klingon language.
Asta Nebula.
Yeah.